This is a strip of atrial flutter. Notice that in the baseline we have these regularly occurring bumps that are approximately 5 little boxes wide. Now we remember from atrial flutter that it is continuous in the atria. Those flutter waves are continuous, they do not stop, and so therefore when you're watching these, as this one ends right here, there is another one here that begins and ends here. So this space is a flutter wave which is being partially obscured by the QRS. Here's the next one, a little taller than these two because there's also a T wave here, so the voltage adds up a little bit to make a little bit of a taller flutter wave there with the T in the middle of it. Here's another flutter and another flutter. There's one hiding under the QRS, partially obscured by the T wave, another one, another one. There's nothing else that can give you these regular bumps in the entire strip, which are very regular. They march out throughout and are way too wide to be P waves. P waves are normally 2 boxes wide, maybe a little bit more, maybe a little bit less, but never 5. When we measure these flutter waves, we get actually 6. That is an acceptable range for atrial flutter, which runs between 250 and 350. 6 divided into 1500 will give us 250 beats per minute for the atria. When you look at the ventricles, you notice they're very regular. There are 23 little boxes between these QRSs, so the ventricular rate is approximately 65 beats a minute. You see a relationship here where there's 4 flutter waves for every QRS. Now, again, some of these are obscured, but they are still there, and you have to train your brain to recognize that there's one of these guys hiding under the QRS, and not to ignore that. One of the ways of doing that is to look at your math relationship. If you take 65 and you multiply it by 4, you do get something around 250. If you take 250 and divide it by 4, you get something around 65. So there is a 4-to-1 relationship between the ventricular rate and the atrial rate. This is approximately quadruple what your ventricular rate is. This is approximately a fourth of what your atrial rate is, a 4-to-1 relationship. When you start measuring these, always start in the same place and end at the same place. So I've chosen the last flutter wave here as the ending point. I put my little mark there. I think that's very helpful. Mark the same place on the next QRS, mark the same place on the next QRS, mark the same place on the next QRS, so you don't get all mixed up. This will be your first flutter wave, your second flutter wave, your third flutter wave, and we're back to the starting point, fourth. A 1, a 2, a 3, a 4, done. A 1, a 2, a 3, a 4. Here I've marked them for you. Here's the first one, here's the second one, here's the third one, and the fourth one. One way of measuring these is take a piece of paper and line it up with this flutter wave here that you've chosen to start with, and this one here. So you've got the measurement of your 4 that are fitting between the QRSs. And then what I would do is just hold up your piece of paper to the 2 QRSs and see how many of your flutter waves fit in there. You can mark your paper here and here and here and here and here and have 4 marks on that paper, hold it up to the QRSs, and you will see it's a perfect 4-to-1 fit. So this guy's going at an atrial rate of 250, ventricular rate of 65, and he is an atrial flutter with a range of 4-to-1.